Hey guys, we're going to work on part 2 of the study guide, 9 through 11. 9 through 11. I'm actually going to work this out on loose leaf because it's going to be a little easier to see than me working it out in this problem. But I'm going to keep this problem up so we can see what we're looking at. All right, so number 9, let's look at number 9 first. So what they want us to do is find x and y. Well, knowing that the line L and M are parallel to one another, we can use our angle relationships to solve for the angle measure. So the first step we're going to do is find the relationship between the two angles that have the same variable. So the two angles that have the same variable will be 10x minus 17 and 8x plus 1. They are alternate exterior angles and are congruent. So we are going to solve this by 10x minus 17 equals 8x plus 1. That's how we set that up. Now we'll just solve for x. So subtract 8x from both sides. Those cancel. We're left with 2x minus 17 equals 1. Add 17 to both sides. We're left with 2x equals 18. And then divide by 2. And we have x equals 9. I don't know where I got the negative 2. There we go. So x equals 9 here. So now that we've found x equals 9, we can now find our y because we know our angle measure for x. So the relationship between 6y plus 29 and 8x plus 1, they are linear pairs, which means they are supplementary. When we have two supplementary angles, we add them together to equal 180. So we can set that up with 6y plus 29 plus 8x plus 1 equals 180. Now, originally we could not solve this because they have two different variables because we cannot combine x and y's. But because we found our x, we can substitute our x in. So 9 into x. So we'll rewrite that. With our new x. So now we can solve it and then solve for y. So then 6y plus 29 plus, we have to solve this first, plus 72 plus 1 equals 180. Next, we're going to add these three together. So 6y plus 102 equals 180. Subtract 102 from both sides. Those cancel. 6y equals 78. And then divide by 6, and y equals 13. So now we have found both our x and our y.